Hi, in this video I will do another example for the test. So the example this time is given the critical points 1, 2 and negative 1 and 2 of the function x cubed plus y squared minus 3x minus 4y plus 1, and the question asks determine what kind of points are these, or will determine the nature. Are they relative max, mean, saddle point, or maybe nothing? Just determine the nature. Well, the good thing about this example is that we don't need to do the critical points. Uh, Maybe if you like, you can pause the video at this stage and really check. You can check yourself. Check that 1, 2 and negative 1, 2 are the critical points. The only critical points, actually. That would be an example for you to do a little bit more things, but while it's given, let's just then do the work here we need. So to do that, to determine the nature, we need to apply the D test. So first, let's find D. Well, for remember D is if at a point AB we want to find D, it is you find fxx at AB, you find fyy at AB, and multiply these two minus square of fxy at AB. Well, for that we need to find what is fxx and what is fyy and fxy. Let me start with the first partial derivative fx, which is, well, I'm differentiating x cubed with respect to x. It is 3x squared plus differentiate y squared with respect to x is 0 minus differentiate 3x with respect to x is 3. Differentiate minus 4y with respect to x, it is 0 plus 0. So this is 3x squared minus 3. Then from there you can find fxx, first partial derivative of fx with respect to x. So fx with respect to x, which gives me, well, here I have only x, so just differentiate. So it will be 3 times 2x minus 0, which is 6x. How about fxy? Fxy is, well, differentiate fx with respect to y. Well, there is no y in it, so when you differentiate, everything is as constant. So 0 minus 0, which is 0. To find fyy, I need to start with fy, which gives me here 0 plus 2y minus 0 minus 4 plus 0, which is 2y minus 4. Then go from there and find fyy. Differentiate 2y minus 4 with respect to y. That just gives me 2 minus 0, which is 2. So D at any given point AB is fxx, this piece here, 6x, oops, let me just, it is 6x times fyy, which is just 2, minus fxy squared, so 0 squared, and that gives me 12. Sorry, let me do this one for all at any point x or y. This is true, yes. Now we will go one by one and check what the D test says for every point, 1, 2, and negative 1, 2. Before I go to the points, just recall that the test says that, well, check the D. If it is positive, if it is negative, if it is 0. These are all possibilities we have. If it is positive, you need to go ahead and do one more step. At that point, check fxx. If it is positive, then AB is a relative mean. If fxx at AB is negative, then AB is relative max. And if D itself is negative, then, well, the point AB is a saddle point. What happens for D equal to 0? Well, if D is equal to 0, unfortunately, the D test is inconclusive. Well, okay, so let's now just go ahead and do point by point. So first for 1, 2, okay? So what is D at 1, 2? Means that D that we found here, we have to set x equal to 1, y equal to 2. There is no y, so it just only need to do this one. It is positive. That's very nice. And well, when it is positive, you see that we have gone this branch. Now we need to check what is the first, the second derivative at that point, fxx. So what is fxx at 1, 2? fxx, we found it is 6x. So we just come back. 6 times 1, this is 6. So for this part, D, so for point 1, 2, D is positive, then fxx is positive, and as you can see, we have gone this branch, and means that 1, 2, point 1, 2 is a relative mean point for f. What happens for negative 1, 2, the other point? Well, we need to find the negative 1, 2. Here it is 12, negative 1 times negative 1 is negative 12. And you just right away notice that this is different in story. Yes, D is negative. When D is negative, so we have gone this way. When D is negative, we don't need to do any other check. Right away, we can conclude that the point is a saddle point. So we can conclude that negative 1, 2 is a saddle point for, well, let me just quickly show you what we did. So basically, first step we did compute what is D, and then for each point we try to apply the D test, check what happens for these ones. And for this function, we notice that we have one relative mean and we have one saddle